So if you use theta times the radius, that will give you the length of the arc. If the theta is measured in
This
radian.
distance.
Right. Okay. And then explain why is the arc important?
Well, the arc is important because it's about the same as CB.
So he's saying that the length here is approximately the same as the length here.
Oh.
He's not able to figure out the length here. Okay, so what they end up doing was the German end up doing was they use this angle theta multiplied by the radius, then will give you the arc, which is approximately the same as CB.
Yeah.
Okay, so that's the idea.
Good,
Okay,
good.
and then what do you do?
So then what you do is you don't. This would work if you knew theta, but that's what you're trying to find. So what you do is, okay, so omega equals theta divided by time. So you can, and since you know
omega
your
is the angular velocity
and your time, you can change this into omega.
So omega is the
angular velocity.
How many angles per second the
telescope. How many
takes?
angles per second?
How many degrees? Because they are following. You are following the
30, like if something, if there were 30 in 6 seconds, then it would be moving 5 degrees per second.
Okay, because the telescope is following the target, so it's moving at a constant angular velocity. Okay.
So
and okay, and then so what do you want to do?
Now that
You can use small.
What you do is CB one segment CB is roughly to omega times range. And then wait.
No. CB should equal to, you should write this and then try to turn into omega.
Okay, so CB, never mind, I skipped this, is roughly equal to,
Just erase it. Just erase it. Rewrite it. Rewrite it here. You got plenty of space.
Segment CB is roughly equal to theta divided by time times r.
Okay, but if you divide by t on one side.
You have to divide by time on both sides. You have to divide CB divided by time also. So CB divided by time equals to omega times range or
prime, right?
Prime, yeah. And then
so this should be a t here. You forgot, right? If you divide by one side by time, the other side also have to be divided by time.
Yeah.
Okay.
And then you, since you're trying to find CB, not CB divided by T, you move C time to the other side by doing the opposite. So it becomes omega times r prime over omega times r prime, no, times time. And then r prime is basically the same, is pretty much the same as r. So you can use r instead of r prime. So CB is omega times r. Oh, no. Sine theta equals to.
So he's going back to this equation.
to CB over VP times T. But then you substitute CB for W times R times T. Oh, sorry, omega, not W. Omega times R times T over VP times T.
Okay.
Then these cancel out. So then sine theta equals omega times range over the velocity of the missile, VP. P is for projectile. And then so theta equals omega times range over the velocity of the projectile, because for smaller angles theta is the same as sine theta
When they are measured in radians. Okay? All right, very good. Do you understand
Very
it,
good,
Dan?
very good, yeah.
Good job, Hans.